Hello everyone. Remember there are 2 assignments still out. I don't remember the date of the bonus MPS assignment, but the assignment 1 and assignment 2, they're like 2 weeks away. But get started on it early in case you have any questions and just in case something comes up. And today first thing we're going to do is we're going to do a brief review of what we did last time. We're just going to do another problem similar to one we did last time where we had the economic order quantity model with stochastic demand. And then we're going to look at how you're going to have an assignment where you build an inventory model spreadsheet. That's an alternative way of making inventory decisions. And there's going to be a whole video and stuff for you on how to do it, but I want to go over it too as well. So those will be the 2 things we do today. Okay. You have a handout that was given to you a week or 2 ago. It says Exam 2, March 12th at the top, March 12th, 2019 at the top. And we're going to be doing number 20 through 24, maybe jump to 26. One thing to know that this was 2019 and I've got some notation changes I've made since then. Notice here it says daily demand. Your sheet has big D for daily demand. I'm only using little d for daily demand now because remember big D is annual demand. And there's also a thing that says targeted service level, 93%. That is the concept of supply chain management, but I'm just setting the service level in stone in a way such that we know to use our 2 standard deviation rule that we're going to do in a second. What we have here in all these problems, I have to give you little c, little r, h, and the lead time. And first question is about what does IID mean. We talked about that last time. I'm going to skip that and go straight to doing some of the problems. Okay. And so the first thing it's asking is what is the expected or average of daily demand over the lead time of 20 days? This is 20, question 20. And we know from our formulas the average demand over lead time is just going to equal mu, the average daily demand, times the L being lead time. And I always have to give you these things. Like in this problem, I give you, we're saying little d, daily demand is distributed identically and independently distributed normally with the mu of 1,000, a mean of 1,000, and a variance of 50 squared, so a standard deviation of just 50. And so mu times L, the average daily demand is 1,000, and then lead time is 20 days. And so that's just going to equal 20,000. Number 21 says, what is the variance of daily demand over lead time? And instead of saying variance of daily demand over lead time, that's a little bit confusing. It's just variance of daily demand, variance of demand over lead time. So this, when you say over lead time, we are talking about the variance of demand over the 20 days. I really shouldn't have the word daily in there. That could confuse you. So variance of demand over lead time. Well, we said that is just, we have I have to give you what the variance is, or in some assignments you calculate the variance from a spreadsheet. And it's just the variance times number of days that lead time is. And in here, I tell you that the variance is 50 squared, and lead time is 20 days. So the variance is 50,000. Then 22, what is standard deviation of demand over lead time? And we saw that's just the standard deviation of daily demand times the square root of lead time. Standard deviation of daily demand was 50. Lead time was 20 days. So this gives us 224 when I round. Number 23, you should place a new order whenever inventory on hand is less than or equal to what point? So again, this is where we're saying, okay, at what point, how low do inventories have to go before we say we need a new order? And in last class we said that we called that inventory level S star, like stock level, and it went by this formula. We take the average demand over lead time, and we add two standard deviations to it. So we have the average demand over lead time, the standard deviation of demand over lead time, and we say the level should be two standard deviations above the mean. And we decide that that level should be 20,448, meaning whenever inventories get that low, that triggers a new order. And you see, that's just a little bit above average demand over that time period, because if you look at daily demand, the average is 1,000. That's kind of a big number, but the standard deviation's only 50. So demand is really pretty predictable for this particular scenario. And then 24, when you place the order, how many units should you order? Just the same as before. We're still using the Q star. Square root of 2RD divided by H. I've given you R and I've given you H, but I haven't given you big D. I've only given some information about little d. And so what we're going to do is we're going to set big D equals to average daily demand times the number of days in a year. So average daily demand was 1,000. 365.25 days in a year. $365,250. And so Q star is equal to the square root 2RD divided by H. 2 is 2. R is 10,000. Big D is 365,250. Divide the whole thing by H, which was 3. $49,346. And so we're going to place a new order of 49,346 units whenever inventory on hand becomes as low as about 20,448. Did that quick because that's just a repeat of what we discussed last time. And there will be an assignment where you have to get your own values of R, D, and H. We'll see that in a minute. And calculate those numbers. Okay. Now we're about to switch to something quite different. You know, I should say, usually this class is very different than it is now. Usually I get to know you really well, where you have more discussions and things like that. We're still in this weird COVID phase. So, like, I don't have any time before class because I got to hook 1,000 things up just to get everything ready for class. I've got like 2 things recording right now simultaneously, and y'all are so spread out. I don't even know what y'all look like most of the time. When I see, especially without, like I met Kylie Burris the other day. She didn't have a mask on. I didn't know who she was. Well, for once, I only see her back most of the time. But even when I do see her face, there's a mask, and I just happened to notice her name. And also, we're having this online section as well. So usually, this class is 60% Chinese students. The China students really like this class because a lot of them want to go on to get graduate degrees in some quantitative business area, like quantitative supply chain management or something like that. But because of COVID, they all had when COVID came last year, they almost all, I think all of them actually went back to China before the semester was over. And they can't come back yet. And so I'm recording this for them. And so I'm trying to not have a lot of little discussions and things that would be meaningless for people watching this. Because I know what it's like to watch a video when you're not really sure if the material is important or not. So I'm going to be really glad when we get back to regular classes where everybody comes. It's amazing how different a class is when you're all kind of huddled close together, for one thing. I can pick on you a little better. I can see what you look like, more discussions, things like, and you can bring your computers and I can actually go around and help you. And the class is a lot more fun. So, I recognize a lot of this, if you like the material, the whole way the class is presented is just not all that great. Now, I wish it was better, but damn COVID, it's not me, it's COVID. Right? The one nice thing about COVID, we can blame everything on COVID. Right? Okay, so we've been talking about this inventory management thing, and we've been doing a bunch of fancy formulas to it, right? We've been doing calculus, and we've been using bell-shaped curves and normal distributions and making assumptions that things are identically and independently distributed. And I feel comfortable, I would feel comfortable using that type of analysis for making decisions because I've spent 2 years of master's, 4 years PhD, and then from 2003 to now, just using math and statistics on a daily basis. It's so familiar to me. I feel comfortable with it. But of course, if you were put in charge of managing inventories for a business, you wouldn't use that stuff. Even if you understood it in class, you're not going to understand it when you get on the job. And even if you try to go back and remember it, you're going to feel kind of uncomfortable with it. You'll see a formula, but you think to yourself, does that really apply here? And so you need to find some other mechanism for using quantitative tools for decision making. And it is true that for a lot of decisions, you don't necessarily need quantitative tools. If you have a lot of experience in something and you just kind of keep some rudimentary data, you could do a really good job of managing inventories. But one reason bigger businesses now tend to have specialized, uniform, somewhat fancy ways of managing inventories is to protect yourself. Sometimes, you're going to see, if you haven't already, that so much in life is style is more important than substance. And so let's say you're managing inventories and you're actually, you can do it without even really thinking that much. You don't need to have an Excel spreadsheet or anything. You're just keeping your own things and things usually go well. But, in the world, random things happen. And suppose something happens that you could not have foreseen, and all of a sudden you're costing your company a lot of money. And then they come to you and they say, what happened here? Why weren't we prepared for this? And you say, well, there's no way I could have foreseen this. And they say, well, what kind of risk management plan do you have? And you say, well, I don't really have a plan. I just, I've got experience in this and I kind of know what to do. And they say, so you don't have any plan whatsoever for how you're managing inventories. And of course you do. You have a plan in your mind, but it's not something that's easily articulated. And you're caught off guard. So even though you may be the best inventory manager the company could have, you look like you don't know what you're doing because there's no plan there, there's nothing written, there's no numbers you can show them. But you can be someone who's actually not very good, but you have this rather big spreadsheet where you put in a bunch of numbers and you tell them, well, we couldn't have foreseen this, we know things are going to happen, we're managing our inventory such that there's only a 1% chance we would ever run out of inventory. And that may be all BS, but you can show them a spreadsheet. You just said 1%, like you really know what you're doing. That sounds like a plan. You say, well, we have these rules about how much safety stock to keep based on data from the past. And you say, well, yeah, we were not prepared for this. So what we're going to do, we're going to take those rules we have, we're going to adjust it. Instead of keeping inventories or rule 2 standard deviations above the mean, we're going to make it 3 standard deviations above the mean, which means there's a less than a 0.05% chance we would ever run out. And well, there you kind of sound like you know what you're doing. And so just as companies who have already decided what decisions they're going to make will bring in consultants to tell the company they should make that same decision, and they do that so if the decision was bad, they can say, well, we also brought in a consulting company and they agreed with us it was the best decision. Having plans, having good spreadsheets, having quantitative models, something you can go to and say, this is how we're making a decision, this is how we can adjustment, is a way of protecting yourself from being blamed on things that were outside your control. And of course, if you're going to have something like that, most people in the business world, they're going to be working with spreadsheets, and the spreadsheet for them is kind of like an extension of their mind. You know, humans are, the human brain is an amazing organ for doing certain things like facial recognition, remembering music lyrics, social stuff, but we're not good at remembering numbers. And we're not good at doing big calculations in our head. But the nice thing is we have these spreadsheets who we can outsource all that to. It can have all that stuff in front of us. And most people, when they're making decisions with spreadsheets, it's a partnership. It's the person with the computer, and the computer's doing the stuff that humans can't do well. The humans are doing stuff the computers can't do well. And those two are working together to come up with good decisions. And usually that person using the spreadsheet, they're putting together some type of model. And here when I mean model, I'm talking about simple calculations using averages, if-then statements, summation statements. But that spreadsheet, they understand. And when they look at how the spreadsheet is put together, it makes sense to them. It's logical to them. They feel comfortable with it. But they would not feel comfortable with an equation that says S star equals mu times L plus 2 times sigma times square root of L. And so what we're going to do here is you're going to have another assignment. We're going to start it here. And it's about, and everybody's going to do it the same way using different data. And of course, there's 1,000 different ways you could build inventory management spreadsheets. But I'm just going to show you one way of doing this, and it's going to be something for an assignment. And I'm going to make a video just like with the forecasting assignment where I had a video showing you step by step how to do it. You're going to have one of those for these, but I want to bring it up here and kind of go through it quickly just so you see in advance what we're doing and the logic behind it. Now, I think, I've got this recording. I think I've got what's being shown on the monitor recording. So for our friends out there on the internet, and for those who go and look back at later, which will be nobody, I'll have the two videos side by side. So you can see what I'm doing on the screen and you can see what I'm doing up here. Okay. And so I wouldn't try to take notes. I would just sit back and watch and listen. And then when you actually go through the video, I think it'll be a lot easier for you. Okay. Okay. So what you're going to do is I've got this spreadsheet already made for you. This is just a template, and you're going to fill it in with stuff. It's an inventory management simulator. Now, some things I'm going to give you are things you wouldn't really, use on the job, but I've got to have some type of standardized way that you're doing this worksheet for me to be able to grade your work. So what we have here, there's going to be some assumptions here. We need to make some assumptions about what ordering costs, holding costs are. We need to make some calculations. We're going to figure out total costs, and our main thing here is to figure out at what point we should reorder and how much we should reorder. And what we're saying is we're going to start with your company. This is one item, let's say it's chicle base, and you have past data. It says daily sales data, but it could be daily chicle use data. And everybody's going to have a different one. Do I have to log in? Do I have to log in? Yeah. Hold on. Okay. You're going to have to open a spreadsheet, and so like Ethan here, he's got his own values for R, H, C, and L, and then he's got his daily sales data. And what I'm going to do the example for me, and I've just chosen somewhere over here. Yeah, so I'm right here, Dr. Norwood is here. I'm going to copy the R, H, C, and L. So I've got those numbers, and then I'm also going to copy all the sales data. So these are my unique sales data. And then you're going to come over here and you got to calculate some other things. So we want to know, well, first off, one thing I do, I guess maybe you don't have to on assignment, but I think it's really useful when you're working with spreadsheets with. So we've got this variable R, 3951, and maybe that's a variable I know I'm going to be using a lot. And so I'm going to give it a name. And what I'm going to do, you give that variable name by going up here in this corner and just typing in a name for it. You can't call it like A2 because that's a cell reference. You got to give it something that's not an obvious cell reference. Can't just say R, that's a column in a spreadsheet. So I'm going to call it coefficient R, C-O-E-F-R. I'm going to call H, C-O-E-F-H. I'm going to call C, C-O-E-F-C. And lead time, COEFL. Okay. I also know I'm going to be using the sales data sum, all these sales data, so I'm going to go and I'm going to highlight the whole thing and give it a name, and I'm just going to call it sales. Okay. And this spreadsheet is going to start with the same model we've been using where we have a S star and reorder point and stuff like that. What this represents is like you're setting up a spreadsheet and you're trying to say, okay, at what point should I reorder? And then you just guess at first and you say, okay, maybe 20,000 is where we reorder. And then you see what the spreadsheet tells you about the outcome is. And you say, well, let me see if I can make that better. Let me start with 21,000. Or maybe go to 19,000. But I need to know exactly where you're starting. So like this starting point has to be the S star that we've been working with. We're going to need estimated annual demand, the big D. And we've been calculating that by taking average demand. So we take average of sales, whatever that is, and those sales are daily sales. We'll take an average daily sales and multiply it by 365.25 for the number of days in a year. And that's how much we think we're going to sell all year. Our Q star, our reorder quantity, Well, that's the square root of 2 times R times D divided by H. So I'm going square root of 2 times coefficient R times coefficient D. I haven't named D yet. So I haven't given the big D a name, so I'm going QEFD. So now square root 2 times R times D divided by H. And we're going to order 54,000 at a time. We need this reorder point, doing it just like we did in that example we did at the beginning of class. To do that, we need average daily demand over lead time and standard deviation of demand over lead time. And we know average demand over lead time is average sales times lead time, COEF. And then standard deviation of demand over lead time is the standard deviation of sales times square root of lead time, 185. And then we know our reorder point is just going to equal average demand over lead time plus 2 standard deviations. So we're starting off with, this is saying that we're going to reorder whenever inventories hit 25,935, and when we reorder, we're going to reorder 54,327. Okay. That's stuff we've done before. That's our starting point. Okay, so this is a way we're going to think about, what we want to do is we want to make a spreadsheet that says on any given day how much we actually have on hand, and the spreadsheet to tell us when we think we'll reorder. So we are doing a simulation here. We're saying we have this rule up here. Our rule was to our rule is to order 54,327 units whenever inventory on hand reaches 25,935. And we're going to do a simulation to say, what if we followed that rule from March 1st, 2019 to July 12th, 2020? How well would that rule have worked? And then we can compare it with other rules. But all you need to do for the assignment is just say, how well would the rule have worked? Then it'll be obvious how you might be able to change it with other rules. I'm going to tell you that on the first date, let's suppose that you begin with Q star inventories. So our first date here is March 1st, so we're starting. I'm going to give Q star a name. Q star is our calculation here, and I'm going to call it capital Q star. So I'm beginning with Q star units. And we're not going to reorder then. You got to initialize the model, give it a starting point. So we're starting off with that. We're not going to have any inventories arising. We're not going to reorder. We've got this much inventory on hand. So on every day, we're going to say, following our rules, how much inventory will we have? Will we reorder on that date? And are inventories arriving on that date? All right. And if you think through this, we think, okay, on the next day, how much inventories are we going to have? Well, we started out with that 54,000 and something. And on March 1st, we actually used 4,909 units. So we think we'll have 49,000, we would have had 49,418. And then we want to have a formula there that says, should we reorder? And the answer is no, because the reorder point was something like 25,000. And so we need a way to tell Excel when to reorder. And the simple rule is we have that S star, right? The reorder point. And if the day before you were above S star, but today you're below S star, that's when you want to reorder. And so I'm going to do, first there's a AND formula. Well, so if we do AND, if first we have this S star that says we order whenever inventory on hand is 25,935 units. I'm going to give that a variable name of S star. And we'll do we reorder. Well, we know that we're going to reorder when two things are true. When inventory on hand today is less than S star, but inventory on hand yesterday was above S star. Let me go ahead, I'm going to copy and paste these down. So it's saying false, false. No, we don't reorder here. We don't reorder here. We do reorder here because inventory went from 28,000 down to 23,000. So we crossed that 25,000 threshold. So now we are reordering. We don't reorder the day after that because the inventories are on their way here. They're going to be here in 5 days. And, you know, we could keep it like that, but somewhere along the way, I got really used to using if statements and like 1 as true and 0 as false. So I'm going to change this. I'm going to include an if statement there. And I'm also doing it just to make sure you have some experience with if statements, but you cannot have enough. When I talk to most graduates who are using spreadsheets a lot, if statements are like if and statements are the most frequently used ones. So we're going to say if that expression, the and expression, is true, put 1, otherwise put 0. So now it's going to hit, give us a 1 every time we cross that reorder point. Now we're seeing something that look right. We've got negative inventories here, right? Obviously we don't want that to happen, but another reason is that we haven't had arrivals yet. So we placed that reorder here, this reorder point, but we don't have anything in the spreadsheet saying when the new stuff comes. And another thing is we know we actually can't have negative inventories. Once you run out, you run out. And so we need to change that equation such that whenever it turns negative, it just becomes 0. And we're going to use the if statement for that. So I'm going to modify, we're going to modify that in a minute. I want to add one other thing to this equation first. Over here we need to have a little thing telling us when reorders are arriving. And to think what that might look like, so we say over here on March 7th, we're going to trigger a new reorder. And then it's going to arrive, the lead time was 5 days later. And so we know the new orders are going to come in 5 days. So that's like we have the first day. And you know, there's always a question of, is the first day the day after you reorder or the day that you reorder? We're going to say it's the day that you reorder. And you'll see that in the video as well. So we placed the order. 1 day goes by. That's the second day, third day, fourth day, fifth day. On that fifth day, the inventory should arrive. So we need this cell where it currently says 5 to equal Q star to say the arrival of new stuff. And so I need this to equal 5. I'm sorry, this to equal Q star whenever that equals 1. And a simple if statement can be done. So I'm going to go if the reorder indicator 5 days ago equals 1, we know we're going to have Q star units arriving, otherwise no units arriving. And so that looks right. You know, we placed an order here, 5 days later, 54,000 new units arrive. And now I just need that formula to be everywhere. Okay. And that looks right, but over here we still have negative inventories. Well, two things. One, because we're not setting inventories equal to 0 when it turns negative, and this formula isn't currently accounting for the arrival of new inventories, so we're going to make those two adjustments. First thing I'm going to do, I'm going to take this equation and I'm going to adjust it to include the arrival of new inventories. I'm going to start over so you can see exactly where everything comes from. So beginning on hand inventory on this date is going to equal inventory on hand from the previous day minus sales from the previous day plus the inventories arrived from the previous day. We're saying the previous day instead of the day because you don't know exactly what time of the day it's going to arrive. All right, so I've got that. And let's see how it's looking. So we start off with 54,000. Every day we draw it down. From this day to the next, we cross that S star threshold. We have to place a new order. And until it arrives, we keep drawing down our inventory. On this 5th day, we're only down to 3,000 units, but sometime on that day, new units arrive. And so that next day, our inventory goes back up. And so we have new inventory. We keep drawing it down. It crosses the threshold. We place an order. We keep drawing it down, and if we did things right, we shouldn't run out before the new order comes in. There's one other thing I want to do to that. There are no negatives here, but it could be that we actually do run out of inventories and the inventories become negative. And if the inventories become negative, I want to change it to 0. So I'm going to take my beginning on hand inventory equation and I'm going to change it such that if those beginning inventories are indeed greater than 0, then just put the equation for beginning inventories. Otherwise, if beginning inventories were negative, put 0. And it goes on down. Now, if you're really using this to make decisions and you're being held responsible for your decisions, you're going to spend a good bit of time looking at what happens during this simulation to see if everything makes sense, to make sure nothing like negative numbers pop up and stuff. And as we're going, looks like the rule works pretty well. Every time new orders come in, we don't have much inventory. So it looks like if we followed this rule in the past, that rule will have worked pretty well. But it didn't have to because that rule was based on assumptions that might not be true. That rule was based on the assumptions that chicle-based usage or sales was independently and identically distributed when it might be that high use on one day means high use on another day. But looking down this looks like a decent rule. But if you're going through here and maybe you see it get to a really low inventory before new numbers come in, you might go back and say, okay, I want to change that threshold to make sure I don't get inventories that low. And you're just going to do a couple more things to the model. And of course, you're not supposed to remember. I just want you to see it all once, because then you're going to watch a video where it goes through again. It's going to be another one of those videos without any audio. You're just going to watch the screen doing it. And I do that because I find that if I add audio to it, I make it really long. You know, my accent, it takes me a long time just to say one word, and I start doing ums, and it's just better without it. And you're sick of my voice, right, Justin? These are the results here. Here I'm adding something else. Something we hadn't talked about yet is like a penalty for if you stock out. You know, for some businesses, if they, you know, like chewing gum on sale at a grocery store, if you go to buy your favorite brand and it isn't there, that's just not a big deal. You're not going to you're not going to all of a sudden not go to Walmart anymore because they ran out of your favorite bubble gum once. But there are some instances where if they run out, that's a big deal. And people will get very, very mad. And so sometimes you want to say in this model, and you don't know what the real cost of running out is. It has to be some kind of guess about how much customers you're going to lose in the future. But you kind of give yourself some kind of, like maybe you say to yourself, you know, if we run out even once, that's like losing $10,000 right now. And you got to give it some kind of number to start with. So that's something we're adding into this model. And so we've got this thing here that says stockout cost, number of stockouts, and you're going to see that in the video you have to actually add something here. Okay. Number of stockouts is equals, it's actually number per year. And so again, we came up with this rule. We've got these past data. We're doing a simulation saying what would have happened if we followed this rule from that first date to the next over that 500 something days. Well, first let's see how many times we would have actually stocked out. Well, we would have stocked out whenever that beginning on-hand inventory equals 0. So all we have to do is calculate the number, count the number of times inventory on hand was 0. And to do that, we can just use there's a count if function. So count if, I want to count inventory on hand. Count if any of those values equaled 0. And none. So following that rule, we didn't have any stockouts. Every customer who wanted to buy one a unit was able to buy one. If we're talking about chicle base, anytime we needed chicle base, it was there. But let's say that but you know, we may want to play with some different rules, see what would happen. So we need to say, what would the cost of a stockout be? And let's say, I'm going to say it's 10,000. So every time there's a day where we run out of inventory, that's like a $10,000 hit to us. And so our total stockout costs here are just going to be the number of stockouts, which happen to equal 0, times the cost of a stockout. Okay. Holding cost, or we're going to do it a little differently. You know, you probably won't remember that a good estimate of amount in inventory all year round is the reorder point Q star divided by 2. But we do know a couple things. We know that we can sum the total amount of inventory we had over all days. So if I sum all this beginning on-hand inventory, that's the total number unit days. That's like the number we had in inventory every day summed over all days. Now, that H variable, holding costs, that was the cost of holding 1 unit for 1 year. So we need to multiply it by daily holding costs. So we just multiply it by the value of H divided by 365.25. And that gives us a different holding cost. Our ordering cost is just the number of orders times the cost of ordering. Well, fortunately, we have, this tells us when we need to reorder, and it equals 1 whenever we reorder. So if I sum all those variables, that tells us the number of times we place an order. Here we place 47 orders, multiply it by the per order cost, and that's our ordering cost. And then the purchasing cost is just the number of units that you order times its per unit cost. And over this time period, we purchased this many units. The per unit cost was C. And we've got that. And now our total costs are just the sum of the purchasing costs, ordering costs, holding costs. Same things that was there before, but also stock out cost. And this tells us that our inventory management cost there is about $8 million. Okay. Now, that was a lot. There's no, you only got a little bit of this. But when you go this and you have to do all those formulas by hand, it's going to improve your understanding of the model, improve understanding what managing inventory is, and improve your use of things like if statements, sum statements, count if statements, things like that. And then what you're going to have to report is just a couple things like the total cost number. And because I know what your sales data are, I can write a program to calculate that number quickly for each student. I can check to see if you have the right number. If you, just like on your forecasting assignment, most of you did, I can quickly give you full points. If you didn't, I'll work with you to see what you did wrong and see about partial credit. Now, what this lets you do is this. Okay, we've got this total cost, and we had this rule up there that we reorder whenever inventories were $25,000. And suppose that people in your company are starting to say that our inventory costs are too high. You won't have to do this on assignment, but this is how you use this stuff. Your people in the company say inventory costs are too high. We need to bring those numbers down. And then you say, okay, well, we've been reordering whenever inventory hits 25,000. Let's see what happens if we change that. And I'm going to copy and paste this right here so we know what the old cost was. So under our previous rule, our inventory management cost was a little over $8 million. Let's come up here and let's suppose instead of reordering when inventory is $25,935, let's change it to $20,000 because management is making me draw down inventories. Somebody who wants to get promoted by changing things at the company is making me do things I don't want to, and I want to show them why this is a bad decision. So I say, okay, we can start drawing down using less inventories, and suppose we change our rule from 25,000 to 20,000. Well, let's see what happens. Wow. Okay, well, we're going to have 45 stockouts if we do that. 45 times a year, we won't have the chickle base you need, and our total costs are going to go up from $8,034,000 to $8,126,000. And so you've got there a defense of why you wouldn't want to do that. And of course, you could go back and say, what if we did 22,000, 23,000, something like that? Well, here's the point here. If someone's making you want to do this, but you've got this spreadsheet and you can show them what would have happened in the past if we had done that, then you may be able to convince them to keep your current management strategy. Because even if they make you change your inventory management strategy and things go awry just like you knew it would, you may still take the blame for it. But if you've got documentation here that says, okay, I can do this, but I think this is going to happen, and it turns out you were right, you've got protection against yourself. And in everything in the world, that protection can be very valuable. And then finally, I leave you with this. And, let me tell you, I spent a good bit of time talking to previous graduates from our department. Sometimes I go visit them at work and see what they're actually doing. And the people who go into, I was talking to a fellow, Cole Galloway, who graduated, I think, in 2006, just yesterday. And I was learning about some of the stuff he does on his job, and he does a lot of spreadsheet work. And it's usually stuff like this. And what you often find, and this may make sense to you if you think about it, is say, okay, we built this tool, and the tool is useful. But often the main value that comes from building these spreadsheets is not the tool itself, but your improved understanding while you were building it. If you build this spreadsheet, you're really deliberately thinking about everything that happens in inventory management, about what happens on a daily basis, about how long it can take something to arrive when you place an order, that there are important things like stockout costs that need to be taken into consideration. And often what happens is the main benefit is just you understand things so much better. That lets you do better in your job in a lot of other ways and helps you come up with creative ideas. Creativity is important. Creativity is not something you can force. We all know this. When we get into an argument and we lose and then we're in the shower, we come up with all these great comebacks. You can't just make yourself come up with an idea. You can't just say, think harder. You've tried this on tests, it doesn't work. Usually best ideas happen in two ways. One, whether you, I think you'll all agree to this, whether you know it or not, your brain is always working on problems. Like you can forget a song lyric and you don't want to Google it because, it just annoys you to have to Google it. You'll just like a day later, it'll pop into your mind, right? And you didn't say, mind, have you thought of that lyric yet? Your mind was working on it and it brought it to you. But sometimes something cued it, like maybe you turn on the radio and there's a song on and makes you remember that other song, and then your brain had found the lyrics for you by then. That's the real key to creativity. It's giving things time, but putting yourself in certain situations, surrounding yourself with certain objects that allows your mind to be creative, because it's something you can't force. Building a model like this, while it seems nerdy and quantitative and it doesn't seem very creative, it does put you in a situation to be creative. Because you're starting off with a model that's really inflexible. It has these rules there. And it's making you focus on just a few things at a time, but it's making you think about inventory management. It's making you think about all the different things involved. And then as time goes by, you come up with creative ways of doing it. The best way for me to write, when y'all write papers, y'all don't do this because you usually just want to sit down and get it out the way. And honestly, we give you good grades no matter how your writing is. But that wasn't insulting, was it? And that's the truth, right? Kinda? But when you're writing something that really has to be good, what I do is I give myself plenty of time to start with. First thing I do is I start writing, knowing that the first thing I'm writing is I'm not even going to use it. I'm not even going to edit it. I'm making myself get starting thinking about it. And I don't take it too serious. I try to write it. I don't force it. And then I walk away. And then I come back to it. I look what I'd written. And something happens. I just know what to do next. I know how it should sound. I know how to rewrite it. And that's how I always do it. And I don't know why the process works like that for me, but it does. And I've read a number of books about creativity and things like that. And that tends to be the general theory of the best way to be creative. By the way, there is a class here anybody taking it called Imagination or something? There's a class in the entrepreneurship department called Imagination, I think. It's all about ideas and everything. Okay, I'm talking too much, I know. Okay, The stuff we did the last 2 days, there's going to be assignments on it. It's going to be straightforward assignments that should be pretty easy for you, including this. Have a wonderful weekend, and do all the things this weekend that I would never do.
What wouldn't you do?
I don't know. That's a good question.